EDU-ARCTIC 2, Polar Research for Education, innovative program in Poland and Norway. Webinars.
Wawrzyniak and I work at the Department of Polar and Marine Research at the Institute of Geophysics, Polish Academy of Sciences. And today I'll be talking about the climate of Svalbard, but also broadly about the climate in the Arctic. First, I'll introduce you to some geographical factors that shape the climate. Then I'll talk about climate conditions in Svalbard. Then I will show you how the meteorology looks like in the Arctic, as I worked as a meteorologist at the Polish Polar Station Hornsund in southern Spitsbergen for a whole year in 2011-2012. And then I'll show you some climate change facts, because there is ongoing climate change in the Arctic and around the globe, but the Arctic suffers the most. The average warming is 3 times or even 6 times higher than for the global average. If you think about the Arctic, some of you live there, so maybe it's nothing new for you. But in the northern hemisphere, Arctic region is surrounding the North Pole and consists of large Arctic Ocean that is surrounded by continents and archipelagos. One of these archipelagos is called Svalbard. There is no one definition of the Arctic, but the most commonly used by scientists is the Arctic is defined by the latitude 66 degrees 34 minutes north. So that's the imaginary line that circles the globe. But having this definition, you would cut parts of southern Greenland. So there's also other definitions. On this map, you can see the green line that shows the tree line. So in this area, above this line, there's no trees, just shrubs and bushes. The red line shows the 10 degrees Celsius isotherm of July. So you shouldn't expect higher temperatures, higher average temperatures in July above this isotherm. The blue line on this map shows the Arctic Circle. So you can see the definition of the Arctic is not really clear, but the most commonly used is the Arctic Circle, so the area above it. Everywhere on the Earth, weather and climate is influenced by many factors and many variables, but the most important one is latitude and sunlight. Because the Earth is round, the solar radiation reaches the ground on different parts of the Earth with different angles. On the equator, the sunlight reaches the ground almost perpendicularly. So sun at noon is just above you. In high Arctic, in polar regions, sun is never that high. So as you can see on the picture, it stays pretty low above the horizon. It's never right above you as it happens in the equator or in lower latitudes. So sun rays that reach the polar areas, they cover larger areas, so they never warmed up as they would be in lower latitudes. So because there is shorter distance and more sun rays reach the smaller region, as you can see, just perpendicularly. Another thing is the Earth axis that is tilted by 23.5 degrees. And depending on where the Earth is on its annual trip around the sun, the northern hemisphere is either tilted towards the sun during summer, as you can see on the picture to the right, or tilted away from the sun in winter. So in winter, there is more sun in the southern hemisphere. During summer, more sun reaches the northern hemisphere. And there is dark season and light season. At the poles, the dark season lasts half a year, and the same with the bright season, so the daylight. And in lower latitudes, there is a longer period with more light and less darkness during winter, as shown on the drawing to the left. The amount of solar radiation that reaches any one spot on the Earth's surface varies according to geographic location, time of day, season, local landscape, and local weather. All the processes in the atmosphere, such as radiation, convection, and aerosol movement, play important roles in shaping the Earth's energy and water cycles. And water cycle is powered by energy from the sun and its continuous exchange of moisture between the ocean, the atmosphere, and the land. So the thing continues. Sun continuously changes the conditions. So we can expect different kinds of weather and different meteorological variables. And what's the weather actually? It's the state of the atmosphere at a particular time. We talk about changes in weather in terms of near future. For example, we say how cold it is right now. I could ask you how cold it is at your place now. You just look at the thermometer, you look through the window, and you can answer me. What's the weather conditions at your place? What it will be like tomorrow, for example. That's another thing that we talk about the weather, because that's something that influences all aspects of our life. We don't feel the average annual temperature changes. We feel what's happening right now in near future, and that's something that is the most interesting for us. But if we do such observations of the atmosphere for a longer period, we can talk about the climate, because weather is the day-to-day state of the atmosphere, and it's short-term variation in minutes to weeks. And people generally think of weather as the combination of the atmosphere, humidity, precipitation, cloudiness, visibility, and wind. And those are basic meteorological variables. But if the weather of a place is averaged over a period of time, at least 30 years, then we can talk about the climate. So climate information includes the statistical weather information that tells us about the normal weather for different places, as well as the range of weather extremes for a local location. And I mean the average air temperature, or the highest recorded air temperature, or the lowest recorded air temperature, and also other variables. There are 4 major climate zones: tropical zone from 0 to 23.5 degrees north, then subtropics between 23.5 to 40 degrees north, in the northern hemisphere, of course, because it's similar on the other side, and temperate zone from 40 to 60 degrees, and then there is polar and subpolar zone from 60 to 90 degrees. And in this region, in polar regions, vegetation is only possible during short summer, during few months per year, and even then the vegetation is often sparse because of harsh climate conditions. And all those conditions are very hard for growing plants and for all animals to live. When winter gets unusually cold in our latitudes, for example, in Poland, people sometimes say that the weather is Arctic. And sometimes that is true, because Arctic air often spreads southward in winter to regions well outside the Arctic Circle. For example, last week in Poland, we have -15 degrees, which was pretty cold, and it was influenced by the Arctic air. But in the Arctic, it's not always very cold. The climate and weather is different than in our latitude, so in the middle of Europe. But it's not always cold, and during summer, it can be even surprisingly warm, even in tundra regions. This year, previous year in 2020, there was the highest temperature recorded in Longyearbyen, plus 22.5 degrees in July. So you would expect it's glaciers, ice, but during summer it can be really warm. This presentation will last for about half an hour, and the climate system is too complex to explain every aspect of it, but you need to know that there's continuous interactions between the atmosphere, the ocean, and the land. So the complexity of that influences what are the weather conditions at different places. For example, oceans have the capacity to store large amounts of heat and transport this heat over vast distances. So it doesn't stay in one place. It's the warmth that reaches the sea can be transported by ocean currents, and they have profound consequences for Earth's climate and ecosystems as well. So not only solar radiation. For example, in northern Atlantic, the Gulf Stream reaches far north, so it reaches even Svalbard. So it also influences the climate there. As you can see in high latitudes, for example, in Greenland, northern Canada, or in Siberia, the temperatures can be much lower than in Svalbard, that is influenced by the warm current called their West Spitsbergen current. And I mentioned about Svalbard, so all those islands between latitude 74 and 81 degrees north and between latitude 10 to 35 degrees east. And that's the archipelago, of which the biggest island is Spitsbergen. And sometimes people confuse those two names, Svalbard and Spitsbergen. But Svalbard is archipelago, Spitsbergen is the biggest island. Svalbard climate is influenced, as I mentioned, by oceanic currents. The West Spitsbergen current brings relatively warm water. So it's warmer there than in northern Greenland. But there's also difference between western and eastern part of Svalbard, because in the east there is East Spitsbergen current. That is cold current that comes from the Arctic Ocean from the north and floats to the south. And that makes the eastern part of the Svalbard colder with much heavier ice conditions. If you think about Svalbard, you have in your imagination usually glaciers, and you are right, 60% of Svalbard is glaciated. But there's also mountains, valleys, and glacially eroded fjord systems. The collection of meteorological data for a long period gives us information that the mean annual air temperature in Spitsbergen is around -6 degrees. The warmest month is July, with mean temperature around +5 degrees. In winter and spring, mean air temperatures are around -15. There is a low annual sum of precipitation, around 500 millimeters in the western part and 200 millimeters in the central part, where Longyearbyen is located. Of course, wind and clouds are very important for how one actually experiences the temperature. Even during summer, it can be really cold, even though the air temperature doesn't reach temperatures below zero, but with strong wind and clouds, it can be really cold. And there are seasons in Svalbard, winters, and also, of course, in the whole Arctic. Winters are long and cold, summers are short and cool, polar night, as I mentioned before, lasts, but for Svalbard, it lasts from the end of October till mid-February. Spring and autumn are just short transition periods. July is the warmest month with 5 degrees, as I said before, but the temperature fluctuations are moderate. There are higher fluctuations during winter, and usually during winter there are temperatures below freezing, but there are days with much warmer temperatures. There is no temperatures below freezing during summer, but during winter the variation of temperature is so high that you can even expect rain events during polar nights. There are around 250 days with snow cover in Svalbard. So as you can guess, the temperatures stay low throughout the year. That's why the snow cover can appear and stay there. Fog is common in Svalbard because of the influence of the mixing of water masses and air at the Barents Sea. So the common weather in Svalbard is precipitation, fog, and even windy conditions. Usually during presentations, people show nice pictures of the sunny weather, but usually it's not that nice because less pictures are taken when the weather is not as nice. Meteorologists acquire, process, and interpret data from different instruments on land, at sea, and in the sky for climate monitoring. And this information is used in weather forecasting and for the provision of meteorological services and products. And it also gives us information about the climate change. In southern Spitsbergen, there is Polish Polar Station Hornsund. This is a place where I work and at which people work throughout the year usually. It started to operation throughout the year in 1978. And I coordinate meteorological monitoring at this station. There is meteorological site next to the Polish Polar Station with all the instruments and equipment for measuring atmospheric conditions. All meteo data collected here helps us to characterize the climate variability in this part of the Arctic. So it gives us information what's the climate in Atlantic sector of the Arctic. And there's lots of different instruments such as ceilometer that gives us information on the cloud base, pluviometers that measure the precipitation, radiometers for UV and solar radiation. And there's also thermometers, barometers, and all the stuff measuring the atmospheric variables. The parameters measured are air temperature, precipitation, air humidity, wind speed, wind direction, atmospheric pressure, ground temperatures, total sunshine, and there's also observations made by meteorologists. They observe what's the cloud cover, visibility, snow cover. They measure the snow cover just to get the information, what's the water equivalent, so how much water will melt from given thickness of snow. There's also information collected on weather phenomena and on sea ice cover. If you're interested in data collected at Hornsund, there is Hornsund website, hornsund.igf.edu.pl. And if you click on the weather, you can check and find the bulletins that are provided every month by meteorologists. And just to summarize the observations in the years 1979-2019, the average annual air temperature at Hornsund is minus 2.7 degrees. A maximum temperature recorded at Hornsund station was plus 16.5 degrees. That was in July 2020. Minimum recorded was in January 1981, and it reached minus 35.9 degrees. Maximum wind speed recorded was 176 kilometers per hour. For scientists, this region is really interested because Arctic regions are highly impacted by the ongoing climate change, and their sensitive geoecosystems are of particular interest. Because they lie in pristine and remote environments, far from proximal anthropogenic impacts, because there's no huge factories, no huge cities in the Arctic. The recognition of the processes happening there help us to understand the impacts and consequences of climate change. So we have lots of instruments in different parts of Spitsbergen, in different lakes, on different mountains. There's meteorological stations, there's sensors to measure ground temperatures, water temperatures, salinity, also sensors that measure glacial movement and other stuff. And I'll show you some results of our investigations. As the station operates as part of WMO, World Meteorological Organization, since 1978, we have good information on changes in climate that are ongoing in Hornsund. And in the last 40 years, we observed the 4.5 degrees warming of annual average temperatures. It's 6 times higher than the global average. So we can see that the temperatures, the average temperatures denoted as the red line, they used to be around -6 in the 80s. And recently, those temperatures are just below 0 degrees, around -2. In case of precipitation, we observe much higher precipitation, especially in the liquid form, so more rain that appears longer because the temperatures are higher, so the summer period lasts longer, and there's more and more rain at Hornsund. So as it used to be around 300, 400 millimeters in the 80s. Recently, we observe even above 800 millimeters per year. And this has huge impact on, for example, glaciers, because the more water, more rain comes onto the glacier, the more it will melt. Here are two charts. The one on the left shows the averaged temperatures during the year, average over 10 years. So the blue lines denote the 80s, the average temperatures in the 80s. The red lines denote more recent decades. As you can see, there is just slight difference in air temperature, in air temperatures during summer, but there is high difference in temperatures during autumn and during winter. So warmer and warmer winters. And on the right, you can see precipitation. Also, blue lines denote the 80s. And recently, there is higher and higher precipitation in August, September, and October. And that's mainly rain. And that's something that is observed at all stations in Svalbard, for example, in Barentsburg, Longyearbyen, Ny-Ålesund, and Isfjord. The trends are similar. The temperatures are higher. In case of snow cover, here the charts, the A shows the snow onset date, B shows snow disappearance date, C shows snow cover duration, and D shows a maximum snow depth. As you can see, there is less and less days with snow cover during the year. At Hornsund, it's minus 10 days per decade. So it means that there is 40 days less recently than it used to be in the 80s. There is also impact on sea ice extent around Svalbard and also in whole Arctic. The sea ice that stays for a long period on the Arctic Ocean and usually is long-lasting, recently is decreasing, and it's decreasing by some 13% per decade. So recently we have around 50% less than we had in the 80s, and the projections show that during summer it can disappear in the 30s of this century. And that's really bad news for the climate of the Earth, because the reduction and loss of snow and ice had the effect of increasing the warming trend, as reflective snow and ice surfaces are replaced by darker land and water surfaces, and dark water and dark land can absorb more and more solar radiation, and that means more warming. Higher temperatures and higher liquid precipitation that I described before lead to prolongation of the ablation season and permafrost degradation. The land used to be frozen for thousands of years in Svalbard, but now permafrost is degraded, so the temperatures are higher and the thawing during summer reaches deeper and deeper. And that means that has huge influence on hydrological processes. So because water cannot penetrate through frozen ground, but as it thaws, it can infiltrate deeper and deeper. And that has influence on biotic systems, on ecosystems. So there's different water conditions for plants and for the animals. And that's something that we also observe. And we observe that streams are active for a longer period than they used to be. The projections, some of them from from Polar Cordex, show that the trend is, positive. So recent temperatures are shown on the left, and that's denoted by the dotted blue line. So that's the average conditions in years 1976, 2005. It is expected to be much warmer in the end of this century, and the worst scenario shows that the temperatures in Hornsund in the end of the century during winter can reach just slightly below zero, or they can be throughout the year above zero, and that means completely different climate conditions. In case of precipitation, higher precipitation is also expected And something that we can observe in the field, especially when we have old pictures, old satellite images, is the comparison of the extent of the glaciers. This picture shows Hornsund Fjord, which is around 40 kilometers long, but it wasn't that long in the beginning of the 20th century. In the middle, the glaciers were reaching the fjord, the middle of the fjord in the beginning of the 20th century. And recently, because of their negative mass balance, they retreat. And recently, they are covering less and less of the fjord. And here are just two images showing July 1990 and July 2017. For the scale, there is this line on the lower right, 5 kilometers. So you can see in these 27 years, most of glaciers, actually all of them, retreated pretty high. And when you have old pictures, as I usually have when I go to the field, I had pictures from 1999, from 2008, 2012, 2014, and there's also pictures from recent years. You can compare the extent of the glacier. So in the upper part, you can see the extent of Hansbren in 1999. Here is its extent in 2008. In 2014 is on the lower part, and here is Hansbren in September 2020. And maybe it's not that surprising for you because you hear about the retreat of glaciers, but once you're in the field and you see the dramatic change that was going on, and you can see the scale of that. Here, just for the scale, are my colleagues, glaciologists. You can see on the lower part, there is this bay in the middle of the fjord, of the glacier, and here are the colleagues for the scale. So you can see in the field, the retreat is super high, and that's something that we also describe in our scientific papers. And the information that we get from Hornsund and also from all Arctic stations are so important that we try to give it to broad to the society, to all the people. And that's something that you can find on in our publications, on different websites, but we don't know how it influences the political decisions. But that's something that has to be taken into considerations for the nearest future, because we know that the highest influence on the climate change is the human activity. The science on human contribution to modern warming is clear. Because of burning fossils, the fossil fuels that run the plants, that run our cars, contribute to the warming. And there is no doubt that since 1950s, the warming was caused 100% by humans. And that's something that you can read in the assessment report given by Intergovernmental Panel on Climate Change, IPCC, that can be found on the internet. Thank you for your attention.
Watch other recordings from webinars on our YouTube channel, youtube.com/EDU-ARCTIC. EDU-ARCTIC 2. From polar research to scientific passion, innovative nature education in Poland and Norway receives a grant of 240,000 euros received from Iceland, Liechtenstein and Norway under EEA funds.